Hello and welcome to Otten Math. In this edition of Otten Math, we are going to work on some practice problems involving the properties of exponents. Okay, so let's start by first evaluating powers of a couple different values that have exponents attached to them. So in this case, I have 7 to the negative 2. Remember, that's just the reciprocal of 7 squared. So that's the same as 1 over 7 squared, which is equal to 1 over 49. Okay, that would be my first answer. Second question, second value that we're supposed to simplify, 9 to the 0. So remember, anything to the 0 is going to be equal to 1. So 9 to the 0 just equals 1. And finally, 3 to the third. It's the same as 3 times 3 times 3. We simply evaluate that. 9 times 3 is 27. Okay. Next, 6 questions. So what we're going to do is we're going to evaluate the expression. We're going to simplify it. We're going to enter our answer as a simple fraction or as a whole number, depending on what happens. And then in the next question, we're going to enter, we're going to decide what properties we've used in order to come up with our solution. So I have 2 to the 0, and that is equal to 1, multiplied by 2 to the negative 5th, which is 1 over 2 to the 5th. So if my math is correct, then 2 to the 5th is going to be 32, but let's just double check. So 2 times 2 times 2, 2 times 2 times 2 times 2, that's 4 2s, 1 more 2 is 5. I have 4 here, 8, 16, 32. Okay, so 1 times 1 to the 32nd, I end up with 1 to the 32nd. So let's talk about the properties that we've used. Well, 2 to the 0, we've used the property, the 0 exponent property. And 2 to the negative 5th, we've used the negative exponent property. So those are the two that we've used. So we use the negative exponent, so we're going to add 4. We've used the 0 exponent, we've had 5. So as we evaluate this, our answer for number 5 is going to be 9. Okay, moving on to, and let's go back and just review what those were. So we have the negative exponent, a to the negative m, is equal to 1 over a to the m. And a to the 0 is equal to 1. So we've used those two in this first question. Now I have 8 over 2 divided by 8 over 3. And that's going to be the same as 8 to the 2 minus 3. Or that is equal to 8 to the minus 1. Or that is equal to 1 over 8. So there are two properties that I use. Let's take a look at the first one. The first one is a quotient of the powers, right? We have 8 squared divided by 8 to the third is the same as 8 to the 2 minus 3, or 8 to the negative 1. So I have quotient of powers property first, and then I have the negative exponent property second. So quotient of the powers, I'm going to add 6. Negative exponent, I add 4. So my answer for number 7 is going to be 10. All right, last one. I have 5 divided by 6 squared, and that's the same as 5 squared divided by 6 squared, which is 25 over 36. All right, and I'm thinking we just use one property, and that's the power of a quotient, right? So we take some value to the m divided by another value to another exponent. We multiply those times some exponent, and we have the power of a quotient. So in this case, our initial exponent, for our example, for each of these is going to be 1. I have 5 to the 1 divided by 6 to the 1. And when I multiply 1 times 2, I get 2. So 5 squared. Again, 1 times 2 for 6. I get 6 squared. And I simplify those values, or express them as 25 over 36. And that's my answer. So again, I'm using the power of a quotient. And so I go back to my guide rule here, power of a quotient. And that's plus 7. So my answer here for number 9 is going to be plus 7. Okay, moving on. Write the number in scientific notation. Okay, so remember the example that I gave to you. I start here, right, where the decimal point is supposed to be. I count how many values I have to move, or how many digits I move, in order to get to a point where that decimal gives me a value between 1 and 10. Okay, so I stop here, 5.27, and I moved 1, 2, 3, 4, 5 decimal places. So I have 5.27 times 10 to the 5th. So when I move right to left, right, my exponent is going to be positive. And when I move left to right, in this case, it's going to be negative. So I count 1, 2, 3, 4, 5 here. 5 decimal places before I get to a value 5.26, which is between 1 and 10. 5.26 times 10 to the 1, 2, 3, 4, 5, to the negative 5. Okay, now I need to write my answer in scientific notation. So in the last two problems, 12 and 13, we're asked to provide an answer in scientific notation. Well, number 12, I can just rewrite this as 3.2 times 1.5 times 10 to the 4th times 10 to the 5th. Because essentially we're treating 3.2 times 10 to the 5th as one value, and 1.5 times 10 to the 5th as another value. So I can rewrite the first part as 3.2 times 1.5, and I end up with 4.8. And then I use my properties. In this case, I'm using the product of the powers, so a to the m times a to the n. So my base is 10. 10 to the 5th times 10 to the 4th is the same as 10 to the 5th plus 4, 10 to the 9th. So going back to the original problem, I have 4.8 times 10 to the 9th. So when confronted with problems like number 12, where you're asked to multiply two values in scientific notation together, you add the values here first that are part of each of the base 10 terms, and then you multiply or add the exponents that are part of the 10 terms together. So I have 3.2 times 1.5 times 10 to the 4th times 10 to the 5th. And I end up with 4.8 times 10 to the 4 plus 5, or 10 to the 9. Okay, in problem number 13, now we're just using the value of the squared value to express 2.8 times 10 to the 3rd. And here we're going to use power of the powers. A to the m to the n is equal to a to the m times n. So going back to our example, I have 2.8 squared times 10 to the 3rd squared. So 2.8 squared times 10 to the 6th. And if we use our calculators, which I need to do right now, we end up with a value for 2.8 squared as 7.84 times 10 to the 6th.